Now we will consider how to find the area and arc length for parametric curves. Specifically where x is a function of t and y is a function of t, where x is f of t and y is g of t. This is the how we find area under a curve. It's the function with respect to x from these x values. So we can convert that to these limits alpha, beta, which are in terms of t. Y, we're just going to substitute in g of t. Dx is going to be f prime of t. Or if we're integrating with respect to y, these will be y values. This function will be written in terms of y. We can convert that into parametric this way. These limits will be adjusted to be in terms of t. X is going to be, by substitution, f of t, and dy will be g prime of t dt. So very simply and directly, that's how we can do this. So let's first find the area enclosed by this curve, and x is t squared minus 2t, y is square root of t, and the y-axis. So let's graph this parametric curve. I'm just going to put some values in for t and see what happens. The domain is something to consider here. I'm going to start with 0 and go positive 1, 2, 4. Let's try these values for t. What does that give me for an x, and what does that give me for a y? Okay. For x, when I put in 0 for t, I get 0 minus 0. All right. For y, when I put in 0 for t, I get 0. Okay. 0, 0 is 1 point. If t is 1, I have 1 minus 2. I have a negative 1 for x. If t is 1, the square root of 1 is 1. If t is 2, I have 4 minus 4. I have another 0. If t is 2, I have the square root of 2. If t is 4, I have 16 minus 8, which is 8. The square root of 4 is 2. All right, so this will just help me get a little picture of what's happening here. These are the points, okay. So it starts here at 0, 0. Okay. And then it goes to negative 1, 1. Okay. And then it goes to 0, square root of 2. So if this is 2, it's going to be here maybe. So this is the, remember parametric curves have direction with them. And then it's going to go out here to 8 to out here like this. Maybe like that. Okay. So what are we supposed to do here? We're supposed to find the area enclosed by this curve and the y-axis. So this is the y-axis. This is the area we are supposed to be finding. All right. So we've done this before in Calc 1, or in this class in Chapter 6. To find the area, if we're going to go with respect to y, we can go take the rightmost x, x sub r, and then we're going to subtract the left x. So we're going to integrate x sub r minus x sub l. dy is basically what we're doing. And so the y values are 0 to square root of 2. This was 0, 0. This was 0, square root of 2. So this is what we're basically looking at here. But we're going to convert all that to terms of t. How do we do that? Okay. Well, first was change our limits to t. What was the value of t at the origin? Well, the value of t was also 0. That's our new limit. What was the value of t at this point? This was 2. T was 2 at that point. So we just changed our limits alpha, beta. F of t is the x function. Okay, the rightmost x right here is 0. And if that is just x is 0 or t is 0. So this is 0 minus this x function is f of t, which is t squared minus 2t. And this dy is g prime of t. Okay, where's g prime? That's square root of t. So y prime, which is g prime of t in the formula, is equal to 1/2 t to the negative 1/2 dt. Is what we're going to put there. 1/2 t to the negative 1/2 dt. All right, this is what we have to integrate and evaluate. So let's see here. 1/2 t to the 1/2 times t squared times a negative is a negative 1/2 t to the positive 3/2. And then I have a negative times a negative, which is a positive. 2 times 1/2 will just give me 1. So this is plus t. 1 plus negative 1/2 is 1/2. So this is what I'm integrating from 0 to 2 dt. Let's integrate. This is negative 1/2. Constant stays in front. X to the 3/2 plus 1 is, t to the 3/2 plus 1 is t to the 5/2 times 2/5. Plus t to the 3/2 times 2/3. We'll evaluate this from 0 to 2. All right, so when we do that, these twos cancel. So basically we have negative 1/5 2 to the 5/2 plus 2/3 2 to the 3/2. And when I plug in 0, it's just going to be a 0. So when we evaluate this, we get, let me just do it real quick. I got negative 26.4 is what I got about right there. So let me just do that again just to make sure. 2 raised to the 5/2 divided by negative 5. Oops. 2 raised to the 5/2 plus 2/3 times 2 to the 3/2. Oh, no. I got 0.754. That is different from what I got before, so I need to, I believe that's the right answer. I'll let you know if for some reason that's not right. Okay, here is the second one. Find the area enclosed by the x-axis and the curve. X is t cubed plus 1 and y is 2t minus t squared. Again, let's plot it to see what we have going on here. So here is an axis. I'm going to throw in some values for t and figure out what my x and my y are. This time the domain is not restricted, so I might put some negative in just to see what happens. Negative 2, negative 1, 0, 1, and 2. Let's put in these values of t, see what happens. All right, this is negative 7 when I plug that in, and this is negative 8. When I plug in negative 1, I get 0. And when I plug in negative 1 for y, I get negative 3. Is that right? 2 times negative 1 minus 1 is negative 3. Yep. 0 is going to give me a 1. 0 for y is going to give me a 0. When I plug in 1, I'm going to get 2 for x and 1 for y. When I plug in t as 2, I'm going to get 9 for x and 0 for y. All right, so let's just get an idea of what's going on here. And keep in mind, this is a very rough sketch because I don't even have scale, hash marked scales. So we'll just see what's going on here. These are ordered pairs, right? Okay, so it starts off, it starts off before negative 2, but let's just say negative 7, negative 8. So maybe this is negative 7, then this would be negative 8. There, we'll start here. 0, x is 0, y is negative 3. So then this is going to be up here. It travels to here somehow. Okay. And then it goes to 1, 0. Then it goes here. 1, 0. Okay. And then it goes to 2, 1, 2, 1. Then it goes here. And then it goes to 9, 0. So this is 2. Oh, I need to make my x-axis longer. 3, 4, 5, 6, 7, 8, 9. It's going to come down here, and then it's going to do something else. It's going to cross. So this is what we have going on here. All right, so what does that mean? that means the area enclosed by the x-axis, this is the x-axis, right? And these curves. So this is the area we're looking for. So we're going to integrate this time using this setup. So we're going to integrate from my x values, 0 to 9, of this curve, y dx. And so what that means is g of t, which is my y, 2t minus t squared dx, or which is f prime of t dt. So that's going to be 3t squared dt. Now I need to change these limits. When these are my x limits, let me change this. When x is 0, when x is 0, no, not when x is 0. This was the wrong limit. We're just hitting the x-axis. This is where y is 0. This is the point 1, 0. So I need to integrate from 1 to 9 for my x values. But I need to change these to my alpha beta in terms of t. So what is the value of t when x is 1? It is 0. I need to change this to my alpha. Alpha is 0. And my beta is when x is 9. Well, when x is 9, t is 2. 0 to 2. All right, so these are my new limits. Let's distribute this and integrate this. 2 times 3 is 6t cubed minus 3t to the 4th dt, 0 to 2. That's going to be 6 over 4t to the 4th minus 3 over 5 t to the 5, 0 to 2. This is going to be 3 halves, 2 to the 4th minus 3 fifths, 2 to the 5th. And then if you plugged in zeros for that, you get 0. So let's just check this. 2, 4 times 3 by 2. I get 24 here. 2 to the 5th. 2 to the 5th. Times 3 divided by 5 times 3 to the 1. Minus 19.2. 4.8. That is the area right there for that guy. All right, next we're going to discuss arc length. My copy got kind of messed up. Given the traced out curve, traced out one time, so this is important, by the parametric equations, x is f of t, y is g of t, where alpha is between, or t is between alpha and beta, then the arc length. So we're just tracing out the arc length for one loop of something, because you know it can cycle many times. It is given by this formula. And the proof of this, again, can be shown in the text, where the arc length is equal to the integral of alpha to beta of the square root of dx dt squared plus dy dt squared dt. So, here we go. Set up an integral and use your calculator to find the length of the curve. X is t plus e to the negative t, y is t minus e to the negative t from 0 to 2. All right, so this is pretty straightforward because they gave us everything. The limits are 0 to 2. The square root of dx dt. Okay, let's find dx dt. What is that? Dx dt is 1 minus e to the negative t. And then to put this under here, we're going to square it, right? So this is 1 minus e to the negative t squared plus dy dt is 1. The derivative of e to the negative t is e to the negative t times negative 1. So this is going to be a plus right there. 1 plus e to the negative t squared dt. All right, so if we use our calculator to integrate this, here we go. Make sure you're in parametric equations, and I am, so that's good. Then we'll just plug this fella in. Hit math, 9. If you've got a TI-84, you may have a fancier calculator, and that's fine. My limits are 0 to 2. And then we're going to say this is all underneath the square root. And the first grouping is 1 minus e to the negative t. Oops. Uh-oh, I didn't mean to do that. E to the negative t, and then I want to press my arrow. And then I want to square this whole quantity, so you can press the x squared. And then it's going to be plus, parentheses, 1 plus e to the negative t squared. And then that ended my everything I wanted underneath the radical. And then that's dt, and I'm going to hit enter. And it tells me 3.14156. And that's the area for that. I mean, not the area, the arc length of that curve. All right, now here we go. Last example. Find the area enclosed by the x-axis in the curve. X is t sine of t, and y is t cosine of t from 0 to 1. So again, they gave us our limit, so that's really super terrific. So the length, the arc length is going to be from 0 to 1, the integral from 0 to 1, the square root. What is dx dt? Well, if x is t times the sine of t, we have to use product rule here because this is a function of t times a function of t. So it's going to be first times the derivative of the second, which is cosine t, plus second times derivative of the first, which is 1. So this is dx dt, and we're going to put that under there and square it. T cosine t plus the sine of t squared plus dy dt squared. Okay, dy dt, if y is t times the cosine of t, then dy dt is going to be, by product rule, first derivative of the second, negative sine t, plus second derivative of first 1, or cosine of t minus t sine of t, cosine of t minus t sine of t, and this is going to be squared, dt. Here we go. Let's square this binomial. Integral from 0 to 1, the square root of, this is going to be t squared cosine squared t plus 2t cosine of t sine of t plus sine squared of t. Let's square this binomial. This is cosine squared of t minus 2 cosine of t, t sine t plus t squared sine squared of t. Oh, I'm running out of room. dt, which is not supposed to be underneath the square root. Okay. Now, is there anything that's going to help us out a little bit? I see a couple of like terms. 2t cosine t sine t, negative 2t cosine t sine t. This plus this is a big old 0. That's wonderful. Sine squared t plus cosine squared t, this is going to turn into the number 1. That's helpful. And then I have this t squared cosine squared t, t squared sine squared t. So I'm going to factor out a t squared, leaving me with cosine squared t plus sine squared t. All right. Which happens to be a 1. So what I'm left with is the square root of t squared plus 1 dt. And so we are going to integrate this. We can just use our calculator for this one. So let's do that. Let us integrate from 0 to 1 the square root of t squared plus 1 dt. And it gives me 1.147, and that is the arc length of this parametric curve.